In this video, we're going to talk about solving equations both graphically and algebraically. First things first, no, I'm not the realist, but if you haven't made a graphing utility your best friend already, you should do so. They're wildly useful, especially when we are solving two different equations or solving for roots like what I have here. So I have a cube function, I have x cubed minus x plus 1, and to the right, I've graphed it using a utility called Desmos. It's an app, it's a website. Use it, know it, it's a lifesaver. And then over here, I have a snapshot of the TI-84. So whether or not you're using a physical graphing calculator or some other app, you can solve for the roots of a function pretty easily. So on Desmos, I just graph the function and I can literally pinpoint, put my cursor on it, and it will tell me what the root of that function is. Now, if you have a physical graphing calculator, if you press the second trace button, which will give you calc, it's going to bring up a menu. And for this, we would use the second option, which is the 0. And you would trace from the left to the right, and it will approximate the 0 for you, much like we have here. Another thing that a graphing utility can do for you is, let's say I have two functions. Let's say I have this 4x to the fourth minus 3 and this linear function 2x plus 1, and I want to find if and where these two things are going to intersect. And I could graph them by hand, super fun times, or I could graph them using something like Desmos or your graphing calculator. So again, on Desmos, you can literally pinpoint where those two things are going to intersect with one another. And also you can do the second trace or the calc menu, and that will give you the intersection. So it will trace along those two curves or lines, and if you find where those two are going to intersect, it will give you those points as well, just like what they've done here in Desmos. So if we can solve a system graphically, we can also solve it algebraically. So let's say I have a rational equation here. I've got two rational expressions, they're set equal to each other. What I'm going to try to do is solve for any values of x that may exist here. Now I'm going to throw it back to middle school and I'm going to cross multiply. Now a common mistake that people make with cross multiplication is that they think they can cross multiply when there is a addition, subtraction, or whatever sign, anything other than an equal sign here. You can only cross multiply when there is an equal sign. Anything else is buffoonery. Don't do it. So we have an equal sign here. I'm going to cross multiply. What I've fast forwarded through is I've distributed and I've simplified, moved over my x's and my constants, and what I have is x is going to be negative 12. Now, something else I have to consider is that the x's are in the denominators, so I know that the x here can't be negative 4 and the x here can't be negative 6, and that's not what I get here. So something else that I need to do is I need to check to make sure that negative 12 actually works, so I'm going to plug it back in real quick. So when I plug my negative 12s back in, I get something that is negative 1/2 equals negative 1/2. That checks, that works. So our solution here is x equals negative 12. And now if I was to look at this graphically, I would plug in my two equations here, y equals this guy and y equals that guy, and I'm going to graph it. Now it looks pretty interesting, and if I actually trace it along, it's going to tell me that the intersection point is negative 12 comma 1/2, which is the solution I reached algebraically. Let's check out one more example. So let's say I have this system of rational equations where this is one equation and that's another equation. So I'm going to solve it algebraically and then check graphically if I'm right. Now, what I have here is I have two different denominators. I've got x squared minus 9 and x plus 3. Now, I know that x squared minus 9 is the same as x plus 3, x minus 3. So that means that this one is missing an x minus 3. I'm going to multiply that out and simplify it now. Something to note here is that because I have the same denominator, I can actually disregard it and just look at the top here. And when I solve for x, I get x equals 3. Now, before I get all hyped and think, all right, I solved for x, this is great, this is going to work, I'm going to check it. So when I plug in 3, I get a denominator of 0 here and 0 here. And as we know, that's not a thing. We can't do that. So there is no solution for this rational equation. And graphically, I can support that algebraic conclusion. So I graph the left side in green and the right side in purple of my equation, and I get this really cool looking graph. Now, the only thing algebraically that could possibly work was 3, although we proved that to not be true. If I look at where x equals 3, this line here, it looks like maybe they touch each other at some point and continue on. It's not quite clear. That's actually something that we call an asymptote. So it's actually going to look like it approaches it, but it doesn't quite get there. So let's say I started with a graph and I wasn't quite sure. I could actually turn to algebra to prove whether or not that's going to have an intersection. And in this case, it doesn't. That's going to do it for this video. Thanks for watching.